All right, Mr. Dodd back with the final unit in continuity. I can determine if the interval or intermediate value theorem applies and apply it. So the intermediate value theorem basically says if there is a sign change and the function over the section being asked about is continuous, the intermediate value theorem guarantees that there's at least one zero in the interval. And I'm just going to use this side section right here to kind of illustrate why. So if I have a graph, I have a point, if I care about this section to here, and I know that it's continuous, if this endpoint is right there, and that endpoint is right there, and I know it's a function, there is no way for me to go get from here to here without crossing the x-axis. Now, I can cross the x-axis more than once, but I have to cross at least one time. So that's like a visual of what the intermediate value theorem is trying to get you to do. First thing we're going to do is determine the continuity on an interval. That's really important. We're going to plug the endpoints in, determine if there's a sign change, and if yes to both steps 1 and 3, the intermediate value theorem applies and guarantees there's a 0, so we will find that 0. So what does that look like in practice? Well, step 1 tells me to determine the continuity on the interval. If I'm looking at this, my interval is from -1 to +1. Are there any problem spots here in this function between -1 and +1? In fact, there's no problem spots at all for this function, so we know that the function is continuous. So it's continuous on the interval from -1 to 1. So that's the first thing. Second thing, I'm going to plug in my endpoints. And what this does is establishes the potential of a sign change. So if I plug in -1, f of -1, that would be -1 minus 1 quantity squared minus 2. That will give me a +2. And then f of 1 will give me 1 minus 1 quantity squared minus 2, which is going to be equal to -2. Okay, the ones cancel, 0 squared is 0, and we go from there. So I have established that my function is continuous on my interval, and there is a sign change. That means the intermediate value theorem, IVT, applies because, B/C, because there is a sign change, and the function is continuous. So now, if the 0 is guaranteed by the intermediate value theorem, which in this case it is, I'm asking you to find it. The way that we find zeros is by solving solutions. We did that in the background information section. I'm simply going to set my function equal to 0 and solve. Just as a quick reminder, the reason this works is solutions occur at the x-axis. The value of y, or f of x, at the x-axis is always 0. So with that being said, I'm going to add 2 to both sides. So that'll give me x minus 1 squared equals 2. I'm going to square root both sides. Super important when you square root a function that you use plus or minus. So anytime you square root, this should be plus or minus the square root of 2. And then I'm going to add 1 to both sides. X equals 1 plus or minus the square root of 2. Now, I would normally box my solution here, but I'm actually not going to in this case. And the reason that I'm not going to, yes, there are 2 places where this solution occurs, but only one of those 2 falls inside of the interval that I care about. There's only one of them between -1 and 1, and that is x equals 1 minus the square root of 2. Okay. 1 plus the square root of 2 is 2 point something something something. So we don't report that one as part of our solution set because it's outside of the interval that we care about. One fact that I just want to make sure that I address before I move on is that it doesn't matter if a function is discontinuous. This one's continuous everywhere, but if I drew a little squiggly right here and drew another function and said f of x equals x divided by x minus 3. What's our problem spot there? Our problem spot is positive 3, right? What if my interval was from negative 2 to 1? Would that function be continuous on this interval? Absolutely. Yes, continuous. But what if my interval was from 1 to 5? Well, now my problem spot, x equals 3, fits within my interval. So this would be not continuous. Okay, so just be aware of that as you go through. We're focused on the interval that's there. Hopefully that's helpful and helps you tackle the end of the continuity unit.